When we expand that first one there, remember that means I'm going to distribute. So I'm going to multiply that 10x to the 6th by x to the 7th. Notice the 10 is going to stay the same in this case. And then when I do x to the 6th times x to the 7th, what do I do at the 6th and the 7th?
Add them.
Yep, exactly. We add them up. And so then that gives me x to the 13th. All right, now I do the 10x to the 6th by the 36x. So the 10 times the 36 is 360. Beautiful thing about multiplying by 10 is all you got to do is add a 0 on the end, right? And then I do x to the 6th times x. That's going to give me x to the power of what? 7, yeah. Good. We're no longer getting thrown off by the x. I like it. And then we do the 10x to the 6th times that 37. The minus stays a minus, by the way. And so 37 times 10 is just 370. And the x to the 6th, it stays x to the 6th. And that's our final answer. That is now expanded. Remember that factoring, which is what we're going to be doing next over here, factoring is the exact same thing, just in reverse. So it's like taking that and turning it into the one with the parentheses. So I'm looking to see what I can undo here. That is like dividing instead of multiplying. So as I take a look at all three of these terms, first up, I look at the numbers. 12, 36, 60. What can I divide all those by? 6, yes. Anything bigger? 12, very good. Yeah, we can actually pull out a 12. Now, I'm going to show you what can happen, though, when you don't grab the biggest number. So I'm going to start by showing you with the 6. That's not going to be the final answer, but I want to show you how to handle it should you find yourself in that situation. Because it's going to happen. All right, and so I looked at the numbers. Now I look at the x's. You notice that we do have an x in every term, but I only have just the one x there. So I'm only going to be able to factor out 6x in that case. Now, when I do that, on that first term, 12 divided by 6 is 2. X to the 8th divided by x is x to the 7th. Remember, we subtract the exponents here. All right. Then 36 divided by 6 gives me 6. X squared now. Minus 60 divided by 6 is 10. And the x divided by x goes away. So how do you know if you did pull out the biggest number? Notice what I have left inside here. 2, 6, and 10. Notice I can still divide all of those by 2. That's how I know I didn't find the biggest number at the start. Now, you got two options at this point. Option 1, go back and restart it and pull out a bigger number. That's just not very much fun, but for some people they prefer to just do that. The other option is, we're going to go ahead and just treat this as its own little polynomial, and we're just going to factor out the 2. So that 6x is still hanging out there. And then this is going to be times, factor out the 2. And we'll clean that up here in a moment. So I factor out the 2, that gives me x to the 7th minus 3x squared minus 5. But then, obviously, I don't want to leave this looking that way. And so, I go ahead and multiply the 6x by the 2, which gives me 12x. And then, notice in this step I didn't change anything inside the parentheses, so it stays as it was in the last line. If you had seen at the very start that 12 was the biggest number you could pull out, you would have gone straight here. And that's ideal, of course. But I do want to at least have you aware of what to do if you don't find the biggest number right away. So this is the focus of today's work. You notice that we're multiplying two different things together, and each of those is a binomial. Hence, this generically is called multiplying binomials. And basically, it's just using distributive property like normal, except it's kind of a souped up version. Now, some of you might have, like when you first saw problems like this way back, maybe even in junior high, you might have seen ones like this. They might have called it the FOIL method. So if you ever heard of the FOIL method, this is the same thing that we're doing here. It's not any different. I'm just not using that term. And also, there's other ways you can remember it too. And I'm going to wait to talk about my way of remembering it until after I've shown you why it works the way it does. All right, so what I'm going to do is I'm going to use distributive property. And remember with distributive property that we were doing yesterday, I took whatever was outside of the parentheses and I multiplied it into both sets. So basically I did one of those. And we can do the same thing with this. If I write it that way now, I would write it as x times x plus 5, and then I'd have to multiply the, then I'd have to multiply the 4 by the x plus 5. And so that's like distributing that whole chunk of x plus 5 to both of those. But notice what ends up having to happen then. If I'm going to do that, that means I have to multiply this x from the first term by both the x and the 5, or this x rather, and this 4 also gets multiplied by both of those. And so I end up doing x squared plus 5x plus 4x plus 5. You'll notice I multiplied everything in the first term by everything in the second term. And when I talk about these types of problems, that's how I describe it as a way to remember it easily. Because you don't have to do this line. If you want to, you can. But for most of us, we're going to go straight to this line. And the way that we do that is that we'll just say, I'm going to multiply this x by both of those, and I'm going to multiply the 5 by both of those. And I'll show you in a cleaner version what that would look like here in a minute, since this one's already got some gunk drawn on there. But I do want to finish this out, because this one's not totally done. Because you notice that I can combine like terms, and I do want to simplify anything I can. In this case, that's just those two, the x terms. Because the x squared, of course, it's got the squared on it, so I can't change anything about it. And so then this is your final answer. This is what we would go. Although there's an error in there that I just noticed. Can you see it?
Yeah.
Where is it? Yeah, I forgot to actually multiply this 4 by this 5. So that should actually be a 20 there. So it's 20. There we go. All right, so we're going to repeat that same process for these. So I'm going to do this by just multiplying everything in the first parentheses by everything in the second parentheses. So first up, I'm going to do x times x, which is x squared. Okay, next up, I'm going to do x times 8, which is 8x. Next up, I'm going to do negative 1 times x, which we can write as negative 1x, or if we want to be a little bit cleaner about it, we could just write minus x. They're the same thing, remember. Whether the 1 is there or not, it means the same thing. All right, and then finally, we need to do the negative 1 times the 8. Negative 1 times 8 is a negative 8. So that's what we do first, is we just multiply everything in the first parenthesis by everything in the second parenthesis. That's it. Then we look to see what we can combine out of that. And you notice there in the middle, yes, there are two terms that just have the x's in them. That'll be fairly common, but certainly not every time. And so we combine our like terms. And 8x minus x gives me a positive 7x. So now on to the second problem. Our process is exactly the same. So x times x, x squared. X times the minus 2, minus 2x. Negative 6 times x, minus 6x. And negative 6 times negative 2, positive 12. You know some of those skills that I've been talking about a lot over the last month? Simplifying expressions, the negatives. A lot of that stuff is coming back in these types of problems, and a lot of that foundational work that we were doing was making sure you could do these. So a lot of it's going back to that, which I mentioned just to make sure that we see that there is just this continuum happening in math where one thing really is building on the next. So I went ahead and combined the like terms. Notice they both are negative, and so a negative 2 minus 6 gives me the negative 8.